So in this problem, we're given a quadratic function, negative 3x squared plus 6x plus 15, and we need to answer a bunch of questions about that function. The first question is asking us to describe, using the set builder notation, the graph of the function f. Well, again, it won't hurt to recall the definition. And whenever a function is given by a formula, say f of x, the graph of that function is the set of pairs x comma f of x, where x runs over all elements of the domain. So in our case, therefore, the graph is the set of pairs x comma negative 3x squared plus 6x plus 15, where x runs over all real numbers, the domain of our function f. That answers the first part. Now, in the second part, we need to complete the square. It should be fairly simple. So we have our function negative 3x squared plus 6x plus 15. Remember, we first factor out the leading coefficient, which in this case is negative 3. So in parentheses, I have x squared minus 2x minus 5. And now, working only inside the parentheses, I see that I have, in this term, twice the first number times the other number, and I see that the other number is negative 1. So I need to add the square of the other number and subtract the square of the other number so that they cancel out. And of course, that's this here is x minus 1 squared and this here is simply negative 6. So that finishes part 2. Before we make a sketch, let's find the image and the x-intercepts. Finding the image is easy because we know, of course, this is a parabola. And from this part, we can easily find where the vertex of the parabola will be, because this really is if I write f as, again, negative 3 times x minus 1 squared minus 6, which is simply negative 3 x minus 1 squared minus 18, or rather plus 18, because x minus 1 squared is always non-negative. Negative 3 times that is always non-positive. And so the whole thing is at most 18, because it's 18 minus a number, rather 18 plus a number that is non-positive. So we're subtracting from 18 this thing which is non-negative. We see that the image of our function is simply all the real numbers that are less than or equal to 18. Of course, the vertex of the parabola will be at that point 1, 18. Image of our function is the interval negative infinity up to 18, including 18. Now, to find the x-intercepts, we can continue again from part 2. Our function is negative 3 times x minus 1 squared minus 6. And I can write this expression in parentheses as x minus 1 squared minus root 6 squared. And now use the formula for the difference of squares. U squared minus v squared equals u minus v times u plus v. So this factors as x minus 1 minus root 6 times x minus 1 plus root 6. And so if I equate f to 0, meaning I'm equating this expression negative 3 times x minus 1 minus root 6 x minus 1 plus root 6 to 0. That is logically equivalent to, since we have a product of two numbers equal to 0, the product is 0 if and only if at least one of the cofactors is 0. So either x minus 1 minus root 6 is 0, or x minus 1 plus root 6 is 0. That's equivalent to x being either 1 plus root 6 or 1 minus root 6. So these are the two x-intercepts. As expected, they're symmetric about the vertical line x equals 1, which is a vertical line passing through the vertex of the parabola. And let's finally sketch the graph as the transformation of the graph x squared. So I should perhaps add a new page. And so the plan will be this. So we graph x squared first. That we know what it looks like. Then remember, it won't hurt to copy our function f. So our function f, on the one hand, is negative 3x squared plus 6x plus 15. On the other hand, when we completed the squared, it's negative 3 times x minus 1 squared minus 6. So next, we graph x minus 1 squared. And of course, we know this will be simply a shift to the right by 1 unit. So the vertex now will be at the point 1, 0. X minus 1 squared. Next transformation is we shift it downward by 6 units to get x minus 1 squared minus 6. Shift downward by 6 units. So the vertex of the parabola will be at the point 1, negative 6. Y equals x minus 1 squared minus 6. Next transformation is, let's multiply by 3 to get 3 times x minus 1 squared minus 6. So that'll be vertical stretch by a factor of 3. Note, by the way, that we will need to stretch the vertical shift of negative 6 too. Right, so now the vertex of the parabola will be at the point 1, negative 18. And now if I can keep the same scale, maybe I can. So the vertex of the parabola will be here, 1, negative 18. And we can continue here, whatever that parabola looks like, and that is again 3 times x minus 1 squared minus 6. And when I finally put the minus in front of this parabola, it'll be negative 3 times that. Of course, we know this will correspond to a flip, a symmetric flip over the x-axis. All right, so let me add a new page. So let's say this will be where my parabola will have its vertex. So this will be 18. And this will be 0. Now, so the final picture will be something like this. Except that, of course, the entire thing has to be shifted. The vertex is at 118. So we know this point here is 1 plus root 6. This point here is 1 minus root 6. This is 118. And this here is finally the graph of f, which is negative 3 times x minus 1 squared minus 6, or otherwise negative 3x squared plus 6x plus 15. So looks correct. Note that, of course, the leading coefficient is negative, and so our parabola has its branches pointing downward, as expected. So the image is indeed from negative infinity up to 18. The vertex of the parabola is at the point 118, and the graph was obtained through a sequence of graph transformations from the graph of x squared. First a horizontal shift, then a vertical shift, then a vertical stretch, which applied to both the graph itself and its previous vertical shift. So 3 is, when you distribute 3 here, you're really shifting not by 6 eventually, but by 18. And then negative in front of 3 resulted in a reflection over the x-axis. So here is the final graph. This problem is now over.